about graphs of quadratic functions. Now, we did this a little bit back in chapter 1 before we started talking about linear functions, but we didn't formally do it, and we didn't formally talk about what it was. We did it on our calculator, and that always can be done. But I wanted to talk about, we have our general form, ax squared plus bx plus c. A, b, and c are real numbers, and of course a is not equal to 0, because if a was 0, it would be a linear function, right? Think about that for a second. And the graph of the quadratic, f of x equals ax squared plus bx plus c, is a parabola with a turning point. So each of these is parabolas. I don't want those there. With the turning point called the vertex. So if my parabola opens up like this, then we have the vertex that is a minimum point. And if it is concave down, we have the vertex that is a maximum point. Now, concave up, if you don't know what concave up and concave down means, it basically, concave up, an easy way to think about this is it holds water. Okay, I call it a happy graph. And this is more like an umbrella. Doesn't hold water, right? And I call this a sad graph. So, and we know that it's the a being positive, so the coefficient of x squared is positive. Here, the coefficient of x squared is negative. So let's talk a little about increasing and decreasing functions. A function is increasing on an interval. Okay, this looks really confusing. If for any x1 and x2 in the interval, when x2 is bigger than x1, then the function is bigger. So what we mean is we're increasing if I can take any 2 points, x1, x2, and when x2, okay, I did that. Yeah, I did it right. When x2 is larger than x1, x2 is greater than x1, then f of x2 is also bigger than f of x1. And it's just going upwards as we go left to right. This is an increasing function. Now, a decreasing function is going to be one in which, I'm going to make one down here. Our decreasing function does just the opposite. If I have an x1 and x2, so here's another x1 and another x2, and now x2 is bigger than x1 still, but f of x1 is larger than f of x2 because we're going downward. We're falling or decreasing. So this is what we used to call a rising function, and this is what we would call a falling function. So another way to think about it. Okay, so let's talk about graphing them. Graphing a quadratic function by hand is quite simple. We can actually find the vertex given this function quite easily. And we know that if a is positive, then it opens down. If it's negative, it opens, or a positive, it opens upward. I didn't like the way this is written. And downward if it's less than 0. So here we have a downward, we have a sad graph. So our vertex is a max. And we find our vertex at negative b over 2a, and the function evaluated at negative b over 2a. So all we have to do is, if we know this, and we know this, we know that there's an axis of symmetry at negative b over 2a, where we can always start and we can always find our vertex. And from there, we can graph these things fairly easily. So let's just talk about how we could graph a function. All right, we're going to graph it on the next page. All right, so let's just look at this and just ask some questions about it. So I see this quadratic function. I say, which way does this open? And I see that a is positive, so it opens up. What is the vertex and axis of symmetry? So then I get negative b over 2a. So b is negative 2. So that's going to be negative 2. Oops, not a. Over 2 times 1, because this is a 1, understood. So my negatives cancel, my 2's cancel, I end up with 1. And now I have to plug that back into the function. So now I want the function at 1, which is 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is negative 4. So I know that I have a vertex at 1, negative 4. So I'm going to go down here, and I'm just going to put this on here. 1, negative 4. Oops, I did that totally wrong. 1, negative 4. I know what I'm doing. Okay. So find the zeros or roots or x-intercepts. So remember, 0 is when my function equals 0. And remember, how to solve these is you have to factor it. So can this be factored? X minus 3x plus 1. I think so. So this means, remember by the zero product property, this means that either one of these equals 0. So either x equals 3 or x equals negative 1. So we know where the zeros are. So now let's put those on there. 3 and negative 1. So now what's the y-intercept? Well, that's pretty easy. That's just when x is 0. So that's f of 0. And that's going to be negative 3. So we know that we have a point at that's negative 3. Now, use symmetry for another point, maybe opposite the y-intercept, or another easy point. So I'm looking over here. I know I have an axis of symmetry right here. So if I have this point 0, negative 3, then I also have this point 2, negative 3 using symmetry. So I have another point 2, negative 3. And then I can use this trick if I need to. This trick, what I'm talking about, use over 1 up or down a, over 2 up or down 4a, over 3 up or down 3a pattern if you have to. So that means I would go from my vertex, and if I go over 1 in either direction, I know this is a happy graph, so it goes up, I go up a. A in this case is 1. So I go up a, up a. If I go over 1, 2, I go up 4. Go over 2, up 4. If I go over 3, 1, 2, 3, I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I know that I have a nice little parabola. And I can tell you I can probably graph them faster. Oh, I didn't do that very well. I can probably graph them faster, some of them anyway, by hand than I can even punching the numbers into a calculator. Now, you could just as easily put that in your calculator and found your nice little graph right there. Okay, so let's try another one. Okay, which way does this one open? Down. So A, this is B, this is C, which is also the y-intercept. We'll get to that in a second. Okay. What is the vertex and the axis of symmetry? So negative b over 2a is negative 8 over 2 times negative 2. Okay, so these negatives will cancel. And I have negative 8 over 4, which is negative 2. So now I plug negative 2 back into my equation. Negative 2, and now I'm negative 2 squared. And be careful with that. Minus 8, negative 2, minus 3. So that is equal to negative 2 times 4, because remember, negative 2 squared times negative 2 squared is 4. And I want to do that as an aside real quick. I want to talk about the difference between negative x squared and negative x squared. Because this is exactly the same as x squared. No difference. This is negative after the x is squared. So if I have negative 5 squared, that's 25. But if I have negative 5 squared, remember by order of operations, exponents are first, so that's negative 25. So just a kind of a note that I wanted to make sure you guys understood. So since this is in the parentheses, it's negative 2 squared, and then multiply by negative 2 again. Then these two negatives will cancel, so that's plus 16 minus 3. So that's negative 8 plus 16 minus 3, which is 16 minus 11, which is 5. So I now know that I have a point at negative 2, 5 that is my vertex. So, sorry, negative 2, 5. All right. So now, let's see if we can find any roots to this. Negative 2x squared minus 8x minus 3 equals 0. When I do this, let's multiply both sides by negative 1. And I get 2x squared plus 8x plus 3 equals 0. So let's see if I can easily find the roots. 2x and x, I don't know, that's 3 and 1 is the only way I can do it. That's 7. If I switch them, that's 5. So there really is not, it's not factorable. We could use the quadratic equation, but we'll get to that later. We're not going to do that part right now. The y-intercept is at negative 3. So we do know we have a spot at 0, negative 3. So we know way down here we have one. So by symmetry, we know we have one that's over here, so we know we have a point over here. That's the only other one we know about right now. So now we know we have a point at, what did I do? Negative 4, negative. So negative 4, negative 3. So we have that point at 0, negative 3, and negative 4, negative 3. So now I do need to use this pattern. So if I go over 1 from the vertex, I'm going to go down, because it's a side graph, I'm going to go down A. A is 2. Well, it's negative 2, so going in the negative direction, 2. So if I go over 1, I go down 2. Over 1, down 2. Now if I go over 2, I go down 4 times A, because that's 2 squared. I go down 4 times A. 4 times A is 8. So go over 2, 1, 2, 3, 4, 5, 6, 7, 8, and that's where that is. So I'm going to go ahead, since I have 5 points, that's what I really need to draw a parabola. It crosses right there. It doesn't look very good. There we go. Okay. And we can easily draw our parabola using those 5 points. Okay, let's move on. Let's talk about maximizing the revenue. Now, Suppose we have the monthly revenue of the sale of Alaska sweatshirts. You know, I like to sell the Alaska sweatshirts, right? Are given by the function negative 0.1x squared plus 50x, where x is the maximum, which is the number of shirts sold. Yes, this revenue function has a little extra thing in it due to supply and demand. So let's first find the vertex and the axis of symmetry. So remember, negative b over 2a. So negative 50 over 2 times negative 0.1. So these negatives will cancel, and we're 50 divided by 0.2, which is 500 over 2, which is 250. So that's the vertex, or that's actually the x-coordinate of the vertex. So let's find what the revenue is when you sell 250 shirts. Negative 0.1, 250 squared, plus 50 times 250. Let's see what that is. Negative 0.1, 625 with 2 zeros, and 125 with 2 zeros. So this is negative 0.1. And so that's negative 625, 0 plus 12,500, which is 6250. So we have our vertex is 250, 6250. What is the vertex? What does the vertex represent, a max or a min? Since this is negative, we have a sad graph, and that means this is a maximum. Interpret the vertex. So the maximum revenue occurs when we sell 250 shirts, and the max revenue we can get is $6,250. That's what that means. So that's really important, because you know I'm always making you guys interpret things. I know I'm weird that way. And so let's graph this function. So we know we have a point 250, 6250. 250, 6250, which would be right here. Okay, we know we have a 0 right there, and we can look at the point opposite the 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we're back here again. And so we know all this. Gosh, I'm terrible at drawing graphs. Oops, lost my... So we could also look at, if I go over 100, so I know the over 1 down 1 thing, but if I go over 100, then I would go over, then I would go down. So 10,000 of 0.1s, so I would go down 1,000. So if I go over 100, I go down by 1,000, which is about what I have here. Oh, 1 down by 1,000. I didn't do it so good on the other side. 350 right here. There we go. That's better. Okay. So there's my graph of the function. Pretty easy, pretty fast. Again, I could also have put that into my calculator fairly easily. And I know, and what's nice about this in this position is that I know exactly where to put the limits now. Because now that I can graph it by hand, I don't have to sit here and guess what the limits are. Oops. So I know if I go to window, let's see, what do I want? 0 to 600. And I'm going to make this 100 just to make it look nice. Y min is 0, Y max 7,000. I'm going to make my Y scale 1,000 just to make it look nice. And look. Oops, what happened? Did we make a mistake? Oh. Oops, I forgot to square my first x there. Okay, so that is insert x squared. Oops, no, we don't need that one. Okay, does that look better? Yes. Now let's graph it. Now it'll be right. And there we go, just like we saw before. And we have exactly the same picture. So really nice. Now we can graph something on our calculator. We can kind of know where to put it. So now I'm going to ask you this question. For what x values is my function increasing? So I'm increasing, if you can see, from x equals 0, well, even below that, but that doesn't make much sense because I can't sell less than 0 product anyway. From x equals 0 up to 250. So from 0 to 250, but 250 I'm not increasing, I'm saying the same. So I can also say from 0 to 250. This is really, really important. So from 0 to 250, I'm increasing. And that's what I'm increasing. And I'm decreasing from 250 to, where else do I hit the axis? 500. So what does this mean in the context of this application? That means my revenue is going up until I sell 250 shirts, but starts going down after that. So basically what's happening is after that many shirts, I'm starting to saturate the market. So I'm not making as much money anymore. My revenue is decreasing. I'm having to mark my shirts down after this. So I can sell about 250. Demand is there for about 250 of them. After that, I can't do it anymore. I start having to mark them down and lower my price to get rid of them. Okay, so let's talk about the height of a ball. This is always fun. So I'm sure you've seen these kind of problems before. So a ball is thrown upward at 32 feet per second from the ground. From the ground? Okay. Write the quadratic function that models the height in feet of the ball. So I've put part of the solution on here. The model has this form. This is how we model a ball. Oops, stop doing that, you darn thing. Goofy thing. Okay. There we go. So -16, that's feet per second squared. That is actually the force due to gravity. And that is always in there. That's the gravitational constant. And then v sub 0 is our initial velocity. So if we throw it upward at 32 feet per second, then what we call our initial velocity is 32. And if we're throwing it from the ground, which good luck with that. I don't know how we're throwing a ball from the ground. We must be standing in a pit. We're going to throw it right from 0. And so our model becomes S of t is -16t squared plus 32t. This goes to 0. This is 0. So that's all we have there. So we want to find the coordinates of this graph. So what is the vertex? Negative b over 2a would be negative 32 over 2 times negative 16. Yeah, that's right. Okay. So negative 32 over negative 32 is 1. So if I plug 1 back into that equation, s of 1 is negative 16 times 1 plus 1 squared, whatever, 32. So 32 minus 16 is 16. So that is the height of s in the function of time. So the t coordinate of the vertex is 1 second, and that isn't when it reaches its maximum height. And the s coordinate is the value at t equals 1. So x equals 16. So at 1 second, it reaches its max height of 16. Okay, so, and for some reason this doesn't want to move, does it? Okay. So finally, we're going to graph this model that we just made. So we know that at 1 second, we are 16. So we know that's the vertex. And we can see that when we go, if we went 0, if t was 0, we would be 0. We can also set this equal to 0, oops, not 16 squared, t squared. We can also set this equal to 0, pull out a negative 16t, we're left with t minus 16. So this is 16 equals 0. Oops, that's 2, and t equals 2. So we can see that, it's just going to be a weird parabola, but that's okay. There's the time, and the max height of the ball is 16 feet in the air. And then it comes back down and hits the ground again after 2 seconds. So, what is the meaning of the coordinates of the vertex? Well, it hits maximum height at 1 second, and the max height that it hits is 16 feet. So we'll do some more fun things with that in class. I'll give you a chance to write that down. It hits a maximum height at 1 second, and the maximum height is 16 feet. Okay, you can pause it if you need to. All right. So now let's talk a little bit about this vertex form. The vertex form looks like this. So we can rewrite our equation where the a is out here in front, and we can rewrite our equation like that. Then we have it in what's called vertex form. And what's really nice about vertex form is the vertex is right there staring us in the face. Nothing needed. Okay, the a is the same as the leading coefficient. It's the exact same number. And the larger the absolute value of a will be, the narrower the parabola will be, which we kind of already know, because that's the same as the other a, right? Again, a greater than 0, parabola opens upward, vertex is a minimum. Less than 0, downward, vertex is a maximum. And we have symmetry in x equals h. So we have this. Okay. So let's use that for the next one. So let's talk about how we can minimize the cost. So the cost for producing X Bluetooth speakers is given by the function c of x equals 0.1 x minus 50 quantity squared plus $1,500. Find the vertex of this function. So the vertex of this function, if we were to see that this is in the form a times x minus, whoops, why is that not? Oh, I hate it when it does that. A times x minus h plus k. Oops, squared. So this is our format that we're in. So remember, the vertex is hk. So the vertex of this function is 50, 1500. That's it. I'm done. I don't have to figure anything out. I just look at it and go, that's the vertex. Is the vertex a maximum or minimum? Well, this is positive. So the vertex, so this is a happy graph. So the vertex is going to be a minimum. Interpret the vertex in the context of this application. Well, it'll be the units that minimize cost. And that's 50 units minimize cost. And the minimum cost is $1,500. That's the lowest our costs can be. So let's graph this function in a window that includes a vertex. So now we want to look at this using our calculator. And again, like I said, now that we have a little more information about how quadratic functions work, it's a little bit easier. So we have 0.1, and then we have an open parenthesis, x minus 50, close parenthesis, there's my squared, just keep it there, plus 1500. So I'm going to go to my window, and there's the vertex of the function. So I'm going to go make sure that I cover the vertex, but I also like to make sure that I cover a little farther than that. I want to cover at least twice what the vertex is. So let's go 150. And I'm going to make my x scale 10. That'll make it good. My y min, well, I can't sell less than 0, so I don't really need that. I need to go at least 1500, but at most 1500, because remember, this is a happy graph. So the 1500 is going to be the smallest it's going to be. So I need to go quite a bit larger than 1500. So let's do 5,000. And then here we'll make the scale 500. I think that'll look a little better. So let's graph it. I can see the vertex. The vertex is right here. So I can actually see the vertex on this. So what I ended up doing was 0 to 150. That was my x. And my y was 0 to 5,000. So I got my vertex in there, and it did just fine. That would be perfectly fine. I could make it a little bit larger. There's a lot of different things I could do. There's absolutely no reason to go below 0 on either one, because neither cost nor units can go below 0 anyway. So this is the minimum cost that we can have. Is 50 units. That lowers our costs the most. So it says, describe what happens to the function between x equals 0 and the x coordinate of the vertex. So between x equals 0 and our x coordinate, so let's go and let's just grab our vertex real quick. Number 3. So left bound, see, I know where the vertex is. So I know to go just below 50. And that's pretty good. Now, one of the mistakes that I saw on the test is people weren't making this bound small enough, and it was giving answers that were off. Enter right bound. I want as close to 50 as I can. And my guess, I can't guess in there, so let's make that. So we notice that we have x equals 50 and y, so we know that. So there's our minimum. So I wanted just to put this x here. So what is happening to the function between 0 right here and my minimum right here? And what's happening is that the function is decreasing. And what that means in the context of the problem is that costs are, like total costs, are decreasing. Between 1 or 0 rather and 50 units produced. So between 1 and 50 units per roots, our total costs are decreasing. So that's what we've learned by that graph. So now let's talk about profit. So Bulk Up Enterprises had its monthly maximum profit, $202,500, when it produced and sold 4,500 cans of protein powder. Its fixed costs is $55,000. If profit can be modeled by a quadratic function of x, the number of cans of protein powder produced and sold each month, find this quadratic function. Okay, so we know something, right? We know that there's a vertex at 4,500, 202, 500. So we know that we have profit function is equal to some a, we don't know what a is yet, x minus 4,500 squared plus 202, 500. We just don't know a. That's where we use fixed costs. Because when our fixed costs is when we make nothing. So at 0, we actually have a negative profit of $5,500, right? Because we make nothing. So what we know is that P of 0 equals A times x minus 4,500 squared plus 202, 500. Oh, that's 0. Sorry. It should be 0. Equals negative 55,000. So what we have here is A times, what's negative 4,500? Let's figure that out. Whoops. Let's quit out of this. Negative 4,500 squared is a very big number. Oops. That should have been in parentheses. I apologize. Negative 4,500 squared. And so we have A times 202,500 with an extra 0 actually, plus 202,500 equals negative 5,500. So let's add this to both sides. So 202,500 minus 55, 1, 2, 3. So this means that 202,500 A equals 147,500. Let's divide that by 202,500, and we get A equals 0.073. So that means that my equation is now P of x equals 0.073 times x minus 4,500 squared plus 202, 500. I think that's right. Yeah. And there we go. And that's our profit function. Something I don't like about it. No, that's probably right. That looks good. Okay. All right. Let's look at this next one. If the points in the table lie on the parabola, write the equation, it only has one, whose graph is the parabola. Well, let's graph these real quick. -2, 5 is here. 0, -1. Oops, I do that all the time. 0, -1, sorry. Y is -1. +2, -3. And 4, -1. So we found two that are the same. So that means we have some symmetry. So we know that this one right here is the vertex. And we also can see the whole thing now. So we know if we go two more out, we go to here. So here's our whole parabola. And we need to work backwards. What was this? So we know that we have this point. This point is our vertex, is 2, -3. So we know that we have y equals a times x minus 2 equals, or no, plus, minus rather, 3. Right? Yes, okay. So we just have to figure out what a is. But I do have this point. I have 0, -1. So I can go y equals a times 0 minus 2. I keep forgetting to do squared. Squared minus 3 equals -1. So I know a times 4 minus 3 equals -1. Adding 3 to both sides. 4a equals 2. A equals 1/2. So I know that y equals 1/2 x minus 2 squared minus 3. And you can leave it just like that. Now, if I really wanted to, I could multiply it all out. 1/2 x squared minus 4x plus 4 minus 3. 1/2 x squared minus 2x plus 2 plus 3. 1/2 x squared minus 2x plus 5. And that is not even right. Oh, because this is minus 3. That's why. -1. Now it's right. Okay. Now it looks better. All right. So again, let's write another equation for a parabola. So here we know the vertex, and we're given one other place. So we have y equals a times x minus h plus k. Don't forget to square it. Y equals a times x minus the y coordinate -2 plus 1. Oh, don't forget to square it. So y equals a times x plus 2 squared plus 1. So let's use this point right here. So x is -1, y is 0. So 0 equals a times -1 plus 2 squared plus 1. So 0 equals a times 1 squared plus 1. So 0 equals a plus 1. So a must be equal to -1. So y equals -1 x minus h, x plus 2 squared plus 1, or y equals negative x plus 2 squared plus 1. You could write this out, negative x squared plus 4x plus 4, then plus 1, negative x squared minus 4x minus 4. So I'd get negative x squared minus 4x minus 3, which that makes sense. And there you go. There's your answer. Okay, one more thing and then I'm done. Now, some of you, I know you've seen it before, the fun, wonderful completing the square. So when you go to find the vertex form of an equation, then what you're going to have to do is complete the square. And I know you've done this before. You might not remember doing this before, but there will be a supplement video about completing the square below this one. So it's fast. It's like 5 minutes, and I know this has been an hour, but I want you to watch that one as well because it is really good. It's a really good video about completing the square. So for this one right here, what we're going to do is when you complete the square is we have y equals 3x squared plus 12x plus 8. So the first thing that I'm going to do is I'm actually going to move the plus 8 out right over there just for a second. Then I'm going to take 3 out of these two times x squared plus 4x. Now what I'm going to do is I need to figure out what I need to add right here that actually completes this square inside here. So what I do is I take half of the x term, half of the coefficient of x, and square. So 4 over 2 squared is 2 squared, which is also 4. So I'm going to do 4. Now, what I actually did is I added 12 to this equation because this 4 is inside this parentheses. Well, I can't just willy-nilly add 4 to an equation. Or add 12, actually. So I have to also subtract 12 back out. So I'm going to say minus 12 at the end. So when I do that, now I have y equals 3. Now I know this is a perfect square, so I'm going to take the number that was half of my b, and I'm going to put that over here, x plus 2 squared, because I know that's the same thing as this. Now I have minus 12 plus 8 is minus 4. So now I have the whole thing in vertex form, and now all I need to do is go, oh, well, what's the vertex? Well, x is negative 2, because this is x minus negative 2, right? And k is negative 4. So there's my vertex. So as soon as I have this thing in vertex form, I can do this. Now I'm going to also show you another video on completing this square so you have a little more practice on it. And that is it, I believe. I'm going to go back and check something. Okay, sorry, I'm not done, and I found my mistake. I knew I had a mistake in here. So I accidentally added instead of subtracted, so this should have been minus 202,500, which would have made this then be, let's bring this back. This should have been, I apologize, I knew it was wrong. Insert negative, so that should be negative, and that's negative 257,500. So this is now negative 25575, and now divide that by this guy, and A is negative 0.127, which that makes a lot more sense that A would be negative. The reason being is because a profit function is generally something like this, because eventually you're going to sell too many items and your price is going to start going down. So generally profit functions will have a maximum and not a minimum, and that's why I knew that it couldn't be negative. So I knew I had done something, I had a little mistake in there. So now you see what the correct answer is, and thanks for being patient, and I will see you in class.